Good morning. Let's go ahead and get started. You can see the quote on the board. Within 5 years, most mobile PCs will have tablet PC functionality. Bill Gates said this around the time we launched the tablet PC. And it's my hope that after we talk this morning, you'll have the tools necessary to go out and start building applications that take advantage of this great functionality that's continuing to build momentum. My name is David Hale, and I'm the lead programmer writer on the SDK team on the tablet PC team. Before I go into the agenda, could I take a quick count and see how many folks have used the tablet PC before? Great. Okay, so almost the majority. And how many of you have written tablet applications before? Okay, a few, a lot less. That's great, because this talk will sort of give you an overview of the tablet platform, introducing the important concepts and objects. We'll look at the object model in a little bit of detail. We'll do some code samples using the object model. Then we'll dive into some of the new features that are coming out with the version 1.7 of the SDK this summer. And we'll talk a little bit more about some tips and tricks for development of tablet PC applications and deploying tablet PC applications. So the tablet platform has gone through 3 basic iterations, even though version 1/1.1, as you can see on the left, was the only difference between 1.0 and 1.1 is that we added some samples and documentation updates in 1.1. In version 1, we included APIs for ink collection, ink data and data manipulation, ink recognition, a couple of controls, ink edit and ink picture, and of course documentation and samples. In 1.5, which shipped I believe January of last year, we updated documentation and samples, but we also added a couple of components, the pin input panel and the ink divider. And then this summer, version 1.7 of the SDK will ship in conjunction with Service Pack 2 of Windows XP. And in that version, we're adding some stylus input APIs that we'll talk about in here today, web support for ink-enabled web pages, more samples, more documentation updates. So since everybody in here, or the vast majority of the folks in here have used the tablet PC, I just want to touch really quickly on the fact that Windows tablet PCs run Windows XP Tablet PC Edition, the operating system. And Windows XP Tablet PC Edition is a pure superset of Windows XP Professional. So all your applications that run on XP Pro will run on the tablet. And then we have the inking functionality on top of that. When SP2 ships later this year, there will be included with the SP2 update an update to the tablet PC operating system, and that update's called Windows XP Tablet PC Edition 2005. The code name for that release is Lone Star. Many of you may have heard mention of that in the press and news groups and that sort of thing. So when I talk about Lone Star, I'm talking about Windows XP Tablet PC Edition 2005. The tablet platform that sits on top of the operating system does 3 basic things, 3 basic areas of functionality. There's ink collection, which is collecting data off of the digitizer on the tablet PC. And then there's ink data management. So once you have that data that you've collected off of the digitizer, what do you do with it? How do you persist it? How do you copy and paste it? And then, if your application requires it, there's a set of APIs around doing ink recognition on that ink data. Now, that's sort of oversimplifying it, but at its core, that's what we do best. Those are the three things that we do. So let's talk a little bit more about ink collection. So every tablet PC has an electromagnetic digitizer behind the LCD panel. So you can use a pen to do basically the equivalent of mouse input functions with a pen. The digitizers on tablet PCs are very high resolution and very high throughput. They are on the order of, the throughput is approximately 10 times higher than a mouse. The resolution is, and the throughput is approximately 3 times as high as a mouse. So that's a lot of data coming across from the digitizer as it moves across the screen. What all this additional data allows for is a very smooth and natural inking experience for the user, and also allows us to present the ink in a very nice, real-world look and feel. There are properties coming off of there. Obviously, there's X and Y, just like with a mouse. But the platform also allows for the collection of additional properties on the data coming across from the digitizer for things like pressure, angle of the pen, rotation. Now, in the current versions of the hardware that are shipping, the only additional property that is available to you is pressure. But and primarily, that's a decision made by the hardware manufacturers to limit the amount of data they're collecting from the pen, primarily around saving battery life. In the future, though, the platform already has support for these additional properties, and as they come online, you'll be able to start using them. And the platform allows you to query the hardware to find out what it does support. Basically, there are 3 components in the API that we'll use for the ink collection part of the process: ink collector, ink overlay, and new in the 1.7 SDK is the real-time stylus. And we'll dive down on each of these as we go forward. The next major bucket of functionality is ink data and management of that ink data. So on the tablet PC, ink is a data type, just like a text or say a Windows media file. It's a data type that you can work with and manipulate, both on the tablet PC and also on down-level machines if they have the appropriate runtimes installed, which we will talk about during the deployment section of the talk. There's multiple persistence formats for the ink data. You can save it in a compressed binary format called ISF, or ink serialized format, that contains all of the ink data and associated metadata around it. There's also what we call a fortified GIF format. This is a regular GIF file, just like you find all over the internet, except for it has the ink data is encoded into a header on that file so that you can round trip to the GIF format and then back into an ink object. It's very good for going down level and then coming back to a tablet. So, as I mentioned before, one of the goals of the tablet platform is to provide a very natural, good-looking ink experience for the user. We do that by making ink vector-based. We use Bezier smoothing to make it look like it would on paper. It's anti-aliased, and you can also do customizable rendering of your own if you want to, using the platform APIs. The API is also extensible in a variety of ways. You can inherit from our ink collection classes. We have APIs that allow you to create your own recognizer engines, and many other ways you can extend the API. And as I mentioned, you can also use ink on the clipboard, and we'll talk about each of these. Finally, that third bucket that I mentioned was ink recognition. So obviously, the idea behind recognition is you take the ink data and then you feed it to an engine and you try to get back a set of results that either are its interpretation of the handwriting that the user was trying to do, or perhaps a gesture that the user was trying to do. You can also have shapes or symbol recognizers. An example here might be one that recognizes musical notes or mathematical symbols and things like that. The languages supported by the tablet PC operating system, I can never rattle these off by memory, so let me pull them up. We have US English, International English, Japanese, German, French, Simplified and Traditional Chinese, and Korean. Those are the ones that shipped in V1. And then later this year, as part of the Lone Star Wave, we'll be releasing Spanish and Italian handwriting recognizers as well. We support synchronous and asynchronous recognition. Even though the handwriting recognizers we have are state-of-the-art and a lot of people think they're the best in the industry, it's still a very processor-intensive process to recognize ink, particularly if you're dealing with page after page of handwritten notes, for example. And so sometimes the better user experience will be had by doing recognition on the background thread and then having it fire an event to you and let you know when it's done to return those results. We'll write some code showing how to do that during the session today. So within the tablet platform SDK itself, we have two full APIs that are roughly equivalent. We have a COM API, automation compliant, so VB6 developers and C++ developers can write to that API set. We also have a .NET API, a managed API for C# and VB.NET and other developers. It's basically a thin wrapper around the COM APIs, and they have just about one-to-one correspondence. We'll be working in C# today, showing code examples, but almost every technique applies equally for the COM APIs. We also have a couple of ink controls, ink edit and ink picture, that we'll talk about a little later. And as I mentioned before, we have documentation and samples in the SDK. And we'll look at some of those samples as well. So here's a sort of high-level, simplified overview of the object model for the tablet PC. At the top, you have the ink collector, the ink overlay. This is where it all starts. When the digitizer, when a pin comes in range of the digitizer and starts generating packets, they go in through the ink collector or the ink overlay. And then that data, once it's funneled from the ink collector, goes into an ink object. The ink object is basically a container for this packet data or this stroke data. A stroke is basically a pin down, pin move, pin up sequence by the user. So every time that happens, there's a new stroke object created. And an ink object holds those strokes. Drawing attributes. There's a drawing attributes object that basically controls how the ink is rendered to the screen. So you have the ink data that contains pressure and all that data, but then you control the rendering and how the ink looks on the screen using drawing attributes. We have a renderer object that you can use both for obviously rendering ink to the screen, but also doing translations from the virtual ink space that the ink data is held in to the device coordinates of the display device or the printer that you're using. We have the tablet object, and the tablet object is used to query the hardware, the actual physical digitizer for capabilities for, what do you support pressure, do you support angle, that sort of thing, and other information about the hardware. And then we have a set of recognizer objects, a collection of all the recognizers that are installed on the machine, individual recognizer objects in reco context. And again, we'll go into more detail as we're writing code against these objects later. Again, this is just a list of some of those objects that we're going to talk about. So let's talk more in detail about ink collection. So what we're going to do during the course of the talk is build up a simple tablet PC application that will, hopefully by the end, collect ink, manipulate that data, and then we'll do some reco on that data as well and return the reco results in the UI of the application. The top-level object for collecting ink is the ink collector. It attaches to any window handle, so you can attach it to a control or a form in your application to start collecting ink. It handles all the input from all attached tablets and cursors. Now, terminology here can be a little bit confusing. When I refer to the tablet object and attached tablets, I'm talking about digitizers that are attached to the tablet PC. Obviously, on a true tablet, you'll have one digitizer that's behind the LCD. Also on the tablet, the mouse, if it's convertible type like this unit that I'm using here, there'll be a mouse attached. That's considered to be another digitizer. It's a poor digitizer. It's not as high resolution as the other digitizers, but it is one that you can iterate through and use for input. You could also use an externally attached HID compliant digitizer, such as the desktop digitizers that a lot of people use for input. And then we use cursors. The term cursor we use to refer to this piece of hardware, which is the pin that drives the digitizer. And a particular physical device can have actually more than one cursor on it. So this one, for example, has one end, two ends. This end is used for input in most applications, and a lot of applications will use this end for erasing. So I'll show you a quick example of that. Windows Journal is an application that ships in the tablet PC operating system. You can think of it as Notepad or WordPad for the tablet PC. It's a note-taking application. So here I'm drawing on Journal some nice smooth ink strokes, and then I just flip the pen over, and when it comes into contact, it will erase that ink. Now you notice that it erased I drew one stroke, and it erased the entire stroke when I touched it with the eraser. That's because I'm in stroke erase mode. There's also you also have the capability of doing point erase, which basically breaks the stroke into multiple stroke objects at the point where you make contact with the digitizer. So that's erasing. That was the wrong way to get back into the slide deck. I won't do that again. Okay. So there are basically three collection modes with the ink collector: ink only, gesture only, and ink and gesture. The ink collection mode means you expect all the data coming off the digitizer to be ink. You know, the person is writing or drawing. Gesture only means you expect the data coming off the digitizer to be a gesture. Now, gesture is just a term used to describe user inputs that are used for command and control type things. They're sort of like, you can think of them as hotkeys. So, for example, inside of Microsoft Windows Journal, when you're writing, there's a gesture called the scratch out gesture that you can listen for. And when you scratch the pen back and forth over the ink, it recognizes that gesture and deletes the ink strokes that are touched by or within a hit test ratio of that scratch out gesture. You can use that same concept in your applications. And then there's the gesture only mode would actually be more useful in a scenario where you had, say, a gesture pad in your application where you wanted, just a little square of screen real estate where you wanted the user to be able to put in commands using gestures. You could listen for gestures only. And then obviously ink and gesture is a combination of those things where it will look at the ink first, see if it recognizes the gesture, tell you about that gesture, and then you can determine whether or not it was the gesture by looking at properties like how confident the recognizer was that that was actually a gesture, and then proceed based on your logic. As if you say it's not a gesture, then you pass it on through, and it becomes an ink stroke. The other ink collecting object is the ink overlay object. It's a pure superset of the ink collector, but it adds editing modes in addition to the collection modes. So the editing modes are inking, selection so that you can just select any stroke or strokes within the window, and delete or erase mode. And this is where you set point. You can have point and stroke erase available. A lot of people ask, when should I use ink collector versus ink overlay? And the general advice is just use ink overlay. The additional overhead is negligible between the two objects, and you get the additional functionality. You get everything ink collector has plus the editing modes. There's also a set of events that happen around ink collection. These are roughly in order that you'll encounter them. So basically, you'll get a cursor in range object whenever the cursor comes within, a few inches of the digitizer, depending on the hardware. Then, as I hover above the digitizer, but before I make contact with it and move around, I'll get new in-air packets events. So basically, it's able to track the digitizer the cursor before it makes contact with the digitizer, and you can get information about that data, like X and Y information. And some hardware even supports distance from the digitizer. Then once the user makes contact with the digitizer and the cursor, you get a cursor down event. Then as the pin moves around, you get the new packets, several new packets events. And as you can imagine, with that high resolution, high throughput data, you can get a lot of these events. So you don't want to do expensive operations when you're handling a new packets event, because you can block. Then once the pin comes up, you'll get a stroke event, letting you know that a new stroke has been added to the ink object. And depending on your mode, well, that actually depends on your mode. If you're in ink and gesture mode, you may get a gesture event before you get that stroke event. And then there's sort of a distinction down here between those events above the line and then those below. System gestures are ones that are system-wide events that are raised that we're always listening for. An example is the right-click gesture that's available. So obviously, when you have a pen that doesn't have a right mouse button, you need an equivalent. And there's a gesture called press and hold that provides that functionality. So, for example, if I stop inking, or go to the desktop, I can do it in Journal. So I'll press and hold, and you see let me do that again. When I press and hold for a couple of seconds, so I put the pin down, I wait, there's a little red icon there, and when I pick up, I get that press and hold event, and I can provide UI based on that. So for example, in Journal here, they pop a right-click menu. And then you also get all the mouse events, regular Win32 mouse events generated by the cursor as well, that you can handle in your application. So let me write some code really quick that shows you ink collection. So we'll go over to Visual Studio, create a new project. Basic C# WinForms application. So we'll write all this code on the fly. There's nothing coming from the clipboard. So prove to you that it actually runs. I'm going to make my form a little bit bigger and add a reference to the tablet APIs. So I have the SDK installed on this machine. So I scroll down, select Microsoft Tablet PC API as my component. Now I have my reference. Now, all I need to do is make sure we're using the namespace, Microsoft.inc. Down inside my form class, I'm going to create a variable to hold the instance of an ink overlay. Oops. Create the variable. We'll just call it ink overlay. Sure, no problem. Let me do that. Up the font real quick. Yep, thanks. You ever notice how you can't think in front of a crowd? 10. How about, I think 18 would be big enough? Is that better? Yeah. Okay, sure. So now down in the form constructor, we're going to new up an instance of the ink overlay. And the constructor for the ink overlay will pass it in the handle for the form itself. So that attaches the ink overlay to the form. Then the only other thing we need to do is enable the ink overlay by setting the enable property to true and run. So now you can see we have smooth, nice ink right there on the form with 3 lines of code. And that's all there is to ink collection. It's pretty simple. Since we attached an ink overlay, we also have access to those editing modes that I described. Let's go ahead and go in and let our user switch back and forth between, say, ink collection and deleting ink. We'll put some rough UI on our form here. Basically, we'll have a button, and the user clicks that button, they'll go from inking mode into erase mode. So say erase, and when they click the button, all we'll do is, so if we're in, excuse me, if we are in inking mode, we'll switch to erase. That's screwy. There we go. Save myself some typing here. Otherwise, we'll swap back over into ink mode. Also, let's be nice to our users and change the text of that button. Let them know which mode they're going to be switching to. Okay. So we'll swap back over. We'll do a little inking. By default, we switch into erase mode. Now notice something that happens here. My cursor changes to the eraser. The ink overlay provides you that service out of the box, so you don't have to mess with changing cursor and that sort of thing. It's in stroke erase by default, so when I touch those strokes, they disappear. So let's look at while we're in here talking about ink collection. Let's look at one more piece of code. When we set up our ink collector, let's change the drawing attributes a little bit so that we can see how we can affect those strokes. So again, up in the constructor, after we've attached the ink overlay, let's actually do it before we enable it. We'll change the default drawing attributes. Say we'll change the color to red. And no surprise here. Now when we ink, it's rendered as red ink. So that just shows you how easy it is to manipulate the drawing attributes on the ink. So that's ink collection. Now let's talk a little bit more about that data. Now that we've collected it and we have it in an ink object, let's talk about how we work with that. As I said before, the ink object is a container for ink data, for stroke data, I mean, and the associated metadata with those strokes, pressure, info, that sort of thing. It also controls all means of persistence for the ink data. There are load and save methods on there where you can persist that data. And you can also use extended properties to extend the data that's saved with the stroke. Basically, the extended properties property lets you add any custom data to the ink object that you need. So for example, you could associate a user ID with a given set of given ink object, or you might date timestamp it, things like that. You could put in the extended properties property. And then below that, all the data is held in individual stroke objects. And like I said, it's a single pin down, move, and pin up sequence. It also supports extended properties, so you can associate that custom application data with the individual strokes. It also supports a drawing attributes property, which is where you control how the stroke is rendered. And there's also lots of rich information on the individual strokes, including things like the size of the individual packets of data, how many of them there are, a description of what those packets contain. You can get at the Bezier points, control points for the smoothing that's done on the stroke, the bounding box, self-intersection points wherever it loops back on itself. So all that math is done for you by the API, and all you have to do is call these properties to get at that. Finally, there's the strokes collection. Now, a strokes collection inside the ink object is a collection of references to stroke objects. It doesn't contain the actual stroke data itself. That's an important concept. Basically, you can have here you have an ink object, and you have stroke 1, stroke 2, stroke 3 inside that ink object. There's a strokes collection property off of the ink object that will give you access, and it references each of those stroke objects. But you can also create, a second My Strokes collection that might reference just, that stroke or these two strokes. The important thing to think about when thinking about a strokes collection is that it's used to sort of group strokes together based on metadata. So you might filter. One example we use a lot is if you had an application that had layers of ink on it. So for example, sort of an onion skin type thing. You might group you have one ink object, but then you group the individual strokes in those layers using a strokes collection for each layer. And that's just how you pass them around. Another place you use strokes collection is to pass data to the recognizer. It takes a strokes collection. Finally, as I mentioned, there's the drawing attributes object. This is where you control appearance of ink with things like transparency and width and the smoothing and anti-aliasing of the ink and that sort of thing. There's a default drawing attributes property on the ink object and on stroke objects, on the ink collection object, so ink collector, ink overlay, and that sort of specifies the default drawing attributes for any strokes collected using that object. You can override those at the stroke level, if you like. or even down to the cursor level. Finally, there's the renderer object. There's basically two coordinate systems on the tablet PC. There's the coordinate system that, excuse me, that contains the ink coordinates. Those are in high metric units. Basically, a high metric unit is 2,540 high metric units per inch, independent of the resolution of the device. And then, so that's the virtual coordinate space that the ink data is held in. And then you have device coordinates for your display or your printer or whatever it is you're rendering to. And the render object will allow you to map between those coordinate systems. There's a couple of methods, pixel to ink space and ink space to pixel, that allow you to do that quickly and easily. And then there's a set of draw methods as well for actually drawing the ink data to the devices. There's also some handy manipulation methods off the render object that support view and object transforms, as well as these helper methods that save you having to do a lot of the transform calculation yourself to do things like scaling the ink, moving it, rotating it, etc. Now, there's a couple of events off of the ink object as well that are useful for sort of monitoring high-level changes to the ink object, ink added and ink deleted. We also support the clipboard. I'm not going to go into a lot of detail about our clipboard support because the following talk that Aaron Goldberg on our team is giving discusses some of the more advanced or nuanced topics of using the ink APIs, and he'll cover that in some detail. Just know that we do support copy and paste to the clipboard in multiple formats, including ISF, HTML, bitmaps, and metafiles. So you can interact with applications that aren't ink aware. So let's do a quick demo of writing some code to manipulate the data once we've collected it. So we'll go back to our project, and what we're going to do is add a handler for that stroke event that we talked about earlier. So we're back in the form constructor. And every time we have a new stroke collected by our ink overlay, inside the handler for that stroke event, we're just going to start by modifying the form, showing how many strokes have been collected. So we'll get at the ink object that the ink overlay is associated with, the strokes collection in that ink object, and we'll get the count of strokes in there. So now let's run that real quick. And you'll see that up in the upper left-hand corner there, as I add strokes, they're incremented 4, 5, 6, etc. Just shows you how you can get at that ink data. Let's do something a little more interesting with that data. What we'll do is, so inside the stroke event handler, you get the an ink collector stroke event args, and the stroke event args include the actual stroke that was generated, obviously. So what we'll do is we'll change the drawing attributes on that stroke that was just created, and just to work with the data a little more, what we'll do is we'll multiply the number of strokes in the ink overlay by 100. So on this machine, the effect that we're going to have here is to basically grow the width of the ink stroke by approximately 2 pixels for each new ink stroke. 1, 2. Oh, you know what I didn't do is to refresh. So after, to cause it to re-render itself. So let's do that. So as you can see, we get wider and wider and wider. Again, so that just shows you how you can affect the drawing attributes of the individual stroke objects and handle the stroke event. Something else that's interesting to note in that sample, sorry, I should have mentioned this, is that, so notice that as I draw it, the ink is rendered, when I draw the stroke, the ink is rendered using the default drawing attributes for the ink overlay object. And then once I release the pen and the stroke event fires, ink collection is finished at that point, and we're talking about manipulating the data. So after the stroke event is fired, then we're into the ink data manipulation portion. And so when the form re-renders is when the thick ink is drawn. So every time I do a pin up and the stroke fires, that's when the drawing attribute is modified. If I refresh before I apply it, I show the code. Okay, so no problem. So your question was, if I refresh before I apply the drawing attributes, I don't think you would see it applied. We can try it. So you see what's happening there. I lifted the pen up, it renders it, but it doesn't apply the attribute until the next time we refresh.
You could change the default stroke at the end of each of these things to anticipate the width of the next stroke, and then it would by default draw it without a refresh.
Right. Sure, that was just a comment. He was saying that you could anticipate that change and have it rendered. He said it better than I'm saying it. Can you say it again?
Change the default stroke width for the next stroke in this handler, so the next stroke is already banner as it's being rendered, and then you don't need a refresh.
Is there a begin, like a begin stroke and stroke event also you can capture?
Well, there's cursor down and there's cursor up, and then there's packet events in between. Yeah, this is just one way. Yeah, sort of high level, quick and dirty way of getting at that data. Okay, I better start moving a little bit quicker to get through everything we want to talk about. So I'm going to move on to ink recognition. The key object when you're working with ink recognition is going to be the recognizer context object. And what a recognizer context object is a specific instance of a recognizer installed on the machine. So as you remember, you have that recognizers collection, which represents all the recognizers that are installed on the tablet PC that you can iterate through to find the recognizer you want. So for example, on this machine, I have the US English SKU of tablet PC operating system. So I have the US English recognizer, I have the International English recognizer, and I have a gestures recognizer. All SKUs of the tablet, no matter what language, will include an English recognizer as well as the localized recognizer. So you can iterate through and find that English recognizer as you need to. But then, so you loop through and you get a recognizer object. Use that recognizer object to find out specific properties about what that recognizer supports. There are various things like whether or not you pass in a guide to sort of influence the recognition results by telling it, the user was writing on a line, or the user was writing vertically or something like that. So you can query the recognizer object for those properties. But then once you actually want to do some recognition, you'll actually generate a reco context, a recognizer context off of that recognizer object, and that's where the work gets done. That's where the heavy lifting of recognition happens. And as I mentioned, you can do foreground or synchronous and background or asynchronous recognition. If you're doing background recognition, you get the results back when these events are fired. You can get a recognition event, or you can get a recognition with alternates events. And I'll talk about the reco with alternates event in just a second. Right now, in fact. So the recognition result, obviously, handwriting recognition, the results are not a clean, definite set of results. I mean, you can have lots of variation between the various results that a recognizer might come back with. And it's not just one word versus another word. So, for example, let's think about the word together. So, depending on how you write it, this word could be together. It could also end up being to gather. Could also be to get her. Could be do get her if your D looks like a T. So, for example, you don't just have a single, there are multiple segmentations of this word that can produce alternate results. And so the point is the recognition result is returned to you in a lattice format that you can then walk through and find the alternates on these various segmentations. So it's a very rich set of results that are returned to you by the recognizer. The value in that is that since recognition is never going to be 100% accurate, you can generate a useful UI for your end user to go in and make corrections to the recognition results programmatically. I'll show you an example of that really quickly. By showing you the new tablet input panel that ships with the tablet PC OS 2005. So the tablet input panel is used for putting text into non-ink-aware applications. So the ultimate non-ink-aware application is Notepad. So when I give Notepad focus here, you'll notice this little icon pops up. And when I click that icon, it brings up the tablet input panel. Then I can just start writing some text. Notice how it grows automatically with me so that I can just keep writing. My mom wishes. And notice it does real-time recognition and provides its best guess at my hand scratching below here. And I can go down and click on these individual words and do in-place correction of the reco. So if this was supposed to be wood, I could just write it in here. And if it had suggestions for my hand scratching there, like this one, it gave me a set of alternates that it took from the reco result and presented, so I can just select if that was supposed to be blob and put it there. So that's an example of using the lattice returned in the reco result object to provide the user with an interface that they can do for correction. Yes, a question?
One question I always get is there a learning recognition?
The question is there learning recognition? The answer is no. The recognizers don't learn from your handwriting. That's definitely something that we're researching and investigating. Some wags like to say that the recognizer trains the user. And it's kind of true. You meet a happy medium somewhere. So that's the recognition result object. Let's write some code that does recognition. I'll write this quickly since we only have a few minutes. In fact, all I'm going to do is create a text box. Drag it on my form. Make the font bigger so we can see it. Then just switch over up. Hit the wrong button. So what I'm going to do is create a strokes collection to hold the strokes that we want to send to the recognizer. And we'll call it strokes to reco. And we're going to create a recognizer context. We'll call it RC. In the constructor, we'll create those objects. So what we're going to do is create that, associate that with the ink object in the ink overlay that we're using create strokes. That creates a new empty strokes collection. Now, I'm showing you some bad technique here because I'm just spinning up a new recognizer context without walking this set of installed recognizers on the system. Because there are variances in how the various recognition engines work, you actually want to walk through the collection, pick the specific recognizer you're using, set the properties appropriately, and that sort of thing. I know I'm on a US English tablet here, and it's just demo code, so I'm just going to spin up the recognizer context and pass strokes to it. So what I'm going to do is set the strokes collection on the recognizer context equal to the strokes to reco collection. And then down in the strokes event handler, the stroke event handler, we don't need to make it big anymore. So all we're going to do in here is add the new stroke to that strokes to reco collection. Now, because I associated the strokes to reco collection with the recognizer context, it's going to be watching this strokes to reco collection. And every time I add a new stroke to it, it's going to pass it to the recognizer context, and it's going to perform reco on it. And then the only thing we need to do now is, of course, put those results. So we need to tell it to perform recognition. And then we need to handle the event that's returned. I'm calling background recognize. So I need to create an event handler to handle the event that's returned by the recognizer when it finishes. So create an event handler. Not doing something right here. Why isn't it creating a... I'm not viewing it. Pardon me? Yeah, but usually Visual Studio will do that for me. That saved me some typing, but oh well. Yes. Thank you. The danger of writing code on the fly in front of 50 people. Pardon?
There's no pressure.
No pressure, right?
Just leave it
Okay. Strokes to reco. Okay, let's look at what we're doing here. Create our strokes collection in a recognizer context. Associate it. Create the new reco context. Aaron, shout out if you see anything obvious going on here. Say again? There we go. Okay. Thank you, Aaron. So in the recognition with alternates event handler, we're just going to set the text box text equal to the top string returned in the recognition result object.
Top string infer that that's the collection of all those ideas that the possibilities.
That's exactly right. The top string means this is the recognition alternate that the recognizer has decided is the highest likelihood of being the correct result. So you notice that as I complete a stroke down in the text box, it's doing incremental recognition and updating the result every time there's a new stroke event, because we're updating that strokes to reco collection. So there's your reco results. Now I think we're supposed to end right now. So what I'm going to do is just skip. Oh, do I have another 15 minutes? I thought I only had an hour. Excellent. We're right on schedule then. So, yeah, I meant to do that. So there's ink recognition. So let's talk a little bit now about some of the controls and components that the platform provides to you. We have a couple of controls that shipped with the first version of the platform. One is the ink edit control. It's basically a superclass of the rich edit control that allows for inking. I'm not going to spend a lot of time on ink edit because with the advent of the new in-place input panel that we looked at a few minutes ago, the usefulness of ink edit is somewhat diminished because it used to allow you to ink directly on the control and then do reco and insert the text results. But now with the in-place tip, you have the in-place correction and all that nice functionality that's probably a better option for your users in most cases. Ink Picture subclass is the picture box control and allows you to, it's basically like an ink overlay on top of a picture box. It allows you to annotate a picture. There's a couple of platform components. There's the pin input panel component, which shipped in version 1.5, again before the new Lone Star text input panel, that allowed allowed you to programmatically control an in-place input panel so that it would pop up much like the input panel does in Lone Star. Again, it's not as useful now that the in-place tip is there, but the APIs can be used to do some high-level control of the new input panel. For example, you can prevent the input panel from popping up in a form in a field in your form using the pin input panel APIs. So they're still there and are still useful. There's also the ink divider object. Now, ink divider is basically an ink analysis engine that will parse the ink that's coming in and provide you with detailed information on its guess as to whether you're drawing words or drawings. It will also break up the ink into individual segments or words, sentences, and paragraphs. Let me give you a quick demonstration of that. In the tablet SDK, one of the samples we ship is an ink divider sample. So the code for what I'm about to show you is available in the SDK. So basically, as I start writing, the ink divider is used to parse the results. And then what this demo does is it takes those ink analysis results and returns them to you and circles what it thinks are words in green boxes and what it thinks are individual lines in the magenta or pink boxes, and then blue is paragraph level. And then if you were to do well, it thinks that's a word, but it also will do drawings as well and return those in red. So, excuse me, this is really useful for analyzing the ink. Another useful feature, and probably one of the key features of using the ink divider object, is that it has the capability of parsing ink that's written sideways. So, and then it also provides methods that will give you transforms that you can use to rotate this ink to a horizontal before you pass it to the recognizer to improve recognition results on that. So this is the same technology that's used in the Windows Journal application to do parsing and ink recognition. So it's available to you in the ink divider object. And as I said, all that code is available to you in the SDK sample for the ink divider. Okay, let's talk about some of the new features in version 1.7 of the platform that ships this summer with Windows XP Tablet PC Edition 2005, which ships with SP2. One of the first major features that we were introducing with this release is known as context. And basically, context is application-specific information that you provide to the recognizers when you pass the ink into the recognizer to sort of provide hints or constraints around what the possible values it should return are. So, for example, if the field that you're entering text into is a URL field, then you can bias the recognizer to return properly formatted valid URLs. So it won't put spaces after periods, for example. We've context-enabled many of the applications that ship in Lone Star, including Internet Explorer and a whole bunch of the Office applications. So, for example, in Outlook, the To field will bias towards valid email addresses. Excuse me. You can set context in programmatically in ink-enabled applications just by setting what's known as the factoid property on the reco context using the format shown here in under examples of context information right here. Excuse me. You can use a set of predefined input scopes, or input scopes are the term we use to describe these types of information that you can bias the recognizer towards. So you can use one of these predefined ones, but you can also create custom input scopes using a regular expression like syntax and these input scopes to combine them together. So you could define a field to say, digit number dash digit number or whatever your, say it was a product ID or something like that. You can also use phrase lists and word lists so you basically the recognizer will pick from a set of words or phrases that you specify. So that's how you do it with ink-enabled applications. Now there's also, of course, many applications that are not ink-enabled, and there's a couple of different ways that you can provide. I should emphasize that, if I haven't already, that the TIP, the input panel, uses this context information when it passes ink for recognition as well. So it's context aware. So, and the way you set context for the fields in your application, you can either use the new set input scope APIs or the input scope APIs, which are documented in the 1.7 SDK, to programmatically set these. It's a Win32 API, and we're also, by probably late next week, we'll have a white paper on our MSD and Developer Center that will show you how to set these from managed code. You can set them programmatically that way. Or you can use the context tagging tool. And the context tagging tool is a tool that we have created and included in the tablet SDK for this release that allows you, it's a non-programmatic way to context enable your application. So you don't have to write any new code. You don't have to recompile and redistribute your executables. All you do is you use the context tagging tool to associate the fields in your application with one of these input scopes, and then it generates an XML manifest file that you then redistribute to your users, and they drop it in the bin, wherever the executable for your application is. You drop it in there next to it, and then at runtime, when the TIP encounters a new instance of your application, it looks for one of these context manifests. If it finds it, it'll load it up and apply that context information to your application. So that's sort of a stopgap measure for you to get context in your application. Yeah? Does the input scope also affect voice recognition? At this time, I don't believe it does. But the set input scope APIs were written as a cross-Microsoft effort with a group that included the speech folks. So, and my understanding is that they're going to start using input scopes, but I don't know when that will happen.
How does that manifest actually get associated with the application?
The question is, how does the manifest get associated with the application? So after you've created the manifest, you distribute it to their users, and they simply just copy that file into the directory that contains the executable for the application. Then at runtime, when the TIP encounters an instance of that application, it looks in the bin directory in there and picks it up. I'll show you how that context tagging tool works really quickly. So here's the context tagging tool. I have a really simple little sample app that I've created. So I just go in and I point at the executable for that sample app, tell it I want to create a new context file, a new manifest. So, and this up in the upper left-hand corner, that's the UI for my app. I have a name field and a date field. So what I want to do is set the context on that date field so that I'm better assured of getting date results returned by the recognizer. So all I do is click to select a control, then drag this sort of cursor icon over onto the field that I'm interested in. And then when I let go, I tell it that, yep, that's the one I want to tag. And I have the list of those input scopes here. I'll scroll down to the date input scope, select it, and then I tell it to coerce to the input scope definition. That means tell the recognizer the only values that it should return are the ones that match that input scope. I add it, and I save my manifest. I'll exit the context tagging tool. Now let me fire up that little app. So I'll try to write something that's not very neat. Yeah, I overdid it. So it returns it as a date. And there's a variety of date formats that are locale specific that it will bias towards. So it uses the locale information on the machine to determine what date format it will use. So it's just that easy. So here's that CTM file or that XML manifest I was talking about. I would just redistribute that file to all the users of my application, have them drop it into the bin directory there with the executable, and now they have context enabled for their app. For 1.7, we've also added web support to the platform. So previously the COM and managed APIs were not usable inside Internet Explorer. Now you can create managed WinForms controls and use them within an HTML page to get inking within web pages. There's also no-touch deployment of tablet PC applications. This means basically you can copy the executable up onto a web server. Users can launch, surf to that URL, launch the executable, and run it in the context of the Internet Explorer application domain. There's ample documentation on this in the new 1.7 SDK. The basic steps to hosting ink controls in IE is to create the WinForms control and ink enable it using ink overlay, or you can use one of the ink picture controls, for example. You just compile it into a DLL library, reference that DLL from the web page using an object tag. Then you can script publicly exposed members from the web page, and that's it. There's a quick start tutorial available in the ASP.NET documentation for how to use WinForms controls in IE, if you want more details on that. Finally, new for 1.7 are the stylus input APIs. I'm not going to go into a lot of detail on these again because Aaron will show you detailed information in the very next talk in this room. But basically, the stylus input APIs give you very low-level access to the data coming off of the digitizer before it ever gets into the traditional ink collection and ink APIs. It gives you real-time access to that data before it makes it to the UI thread. You're still on this inking thread, so it's very flexible, and you get better performance than you do with the ink overlay and other ink collection objects. The stylus input APIs are built with the architecture of them is a plug-in based model. So what you can do is there's a thing called the real-time stylus object that you can then create an object that implements the stylus input API's interfaces, and then just plug it into this real-time stylus on that real-time thread, and then the packet data is passed down through the set of plugins associated with the real-time stylus before then being queued up to be passed on to the user interface thread. Very briefly, I'll show you an example that might clear up what that's all about. So this is another sample that ships to the 1.7 SDK. All the code for it is available in the SDK. This is a simple sample that provides a set of plugins. Basically, there's a packet filter plugin, a custom dynamic renderer plugin, a gesture recognizer, and a dynamic renderer. I'm going to turn off everything except for the dynamic renderer to show you that basically that works just like a regular ink collector. But then if I turn on this packet filtering plugin, what the packet filter plugin does is it looks at the data coming across from the digitizer, and anything outside of a specified arbitrary area, in this case it's a square, it doesn't allow packets to be collected outside of that. So if I start inking in the middle of my screen here, it's fine. But then when I reach the edge of that section, you'll notice that it won't let me ink outside of this square. I can go in and do whatever I want, but then when I go out, so I have basically what I have here is a disabled region for inking on my form. Now you can also do a custom dynamic renderer. So here what we've done is created one that creates little green circles when it renders. I've still got the packet filtering plugin turned on, so I can't ink outside of that. Now when it gets interesting is I'll turn the dynamic renderer back on, I'll leave the custom dynamic renderer on, and I'll change the order of these plugins as they're associated with the real-time stylus. And I'll move the packet filter down below the dynamic renderer. Now when I ink, the dynamic renderer does not have the packet filter plugin applied, but the custom dynamic renderer does not have the packet filter plugin applied, but the dynamic renderer does. So it's limited by the packet filter, but the custom one is not. So it just shows you how you can change the order, and it influences how the packets are handled by the real-time stylus. So this gives you a whole new level of control over the data coming from the digitizer in your application that you didn't have before. And again, all the code for that sample is available in the SDK. Finally, in 1.7, we've changed the API a little bit to allow you to create strokes with full packet information. Previously, you could only create strokes programmatically with X and Y data. Now you can specify any packet description information you need when you create those strokes programmatically. We've added an HTTP user agent string so that now you can determine easily from your web applications that the user is coming from a tablet PC and adapt the user interface in smart ways, taking into consideration that they may likely be using a display that's in portrait instead of landscape mode, for example. Or you can determine if they'd be able to accept one of these ink-enabled controls. And then we've, as I've mentioned throughout the talk, enhanced the documentation and samples in the SDK tremendously. So some real quick basics on what it takes to get started writing tablet applications. You do not have to have a tablet PC to write tablet applications. You can install the SDK on any Windows 2000 SP3 computer and above. The SDK is downloadable from MSDN. You can develop on that environment with a couple of caveats. The first is the recognizers are not included with the SDK, so you can do everything except for call methods that require recognition to occur. One workaround for that is if you're an MSDN subscriber and you have access to the Microsoft operating systems, you can get the tablet PC operating system from that subscription and install it on your desktop machine. In which case you'll have the full meal deal. You'll have the recognizers and everything else. You could use your mouse for input, or if you had an attached digitizer with a HID driver, you could use it for input. We always do recommend, though, that you test whatever applications you build in the real tablet PC environment, even if you're developing on a desktop, so you can make sure, particularly to test for some of the nuances around user interface experience differences between a tablet and a desktop, such as screen rotation. And again, like I mentioned, you can use an external HID digitizer or your mouse for input in that environment. Finally, to deploy your tablet application, use the redistributable merge modules that come in the SDK. There's a set of these files that you can include in your setup project that will distribute the necessary components that are needed for people on non-tablet operating systems to view ink in ink controls, for example. Keep in mind that they will not have recognition available to them on these down-level machines or non-tablet machines. If they do ink collection, they'll be using just a regular old mouse, more than likely, for input, so they won't have high-resolution input. There's no pin input panel and tablet input panel or TIP support on those systems, obviously. And we do not support ink on the Win9X family of platforms. And finally, we're announcing here at TechEd the Tablet PC Developer Center on MSDN. So now if you go to msdn.microsoft.com/tabletpc, you can get at a whole suite of new technical articles, downloads, other developer resources, as well as some regular columns that we're writing, including one called Mobile Ink Jots, which will sort of keep you abreast of current happenings in the ink and tablet development space, as well as a Tablet 101 column where you, over time, will take you through more details in some of the things we've talked about in this talk today. There's also links to the news groups. There's a pretty active tablet development news group out there that's patrolled by developers on our team, and they're there to help you and answer any questions you have, as well as the MVPs who are very active and very knowledgeable in this space, and featured partners. So go ahead and check out the Tablet Developer Center. It's a really great place to go and get started with development. Sure thing. The URL, again, is msdn.microsoft.com/tabletpc. And one more thing to mention is a contest that we have ongoing right now for ISVs who are interested in writing tablet applications. You can get more information about this contest at www.doesyourappthinkandink.com. And the grand prize for this contest is $100,000. So if you write the best application and it wins the contest, that's the prize. So please go there and check that out if you're interested. I believe that ends this summer. You can find out the exact date at that URL. So please fill out a session evaluation. I appreciate your time today. I'll be around to take any questions that you have. And also, please remember that Aaron will be doing an advanced talk right after this one. Thank you. Sure. Yeah. If you have questions, please say them into the microphone. Yeah.
I don't think it's on.
Hi, Julie. Is it not on?
Maybe it is. Is it? Okay. You know me. I have a couple of questions. Maybe it's not on. I can talk really loud. It's okay.
I think it was.
When you're using the delete method or when you set the
delete mode.
Delete mode, and it's not in the default mode of delete a stroke, and you're doing it so that it breaks up the strokes. How does that affect the stroke collection?
How does that affect the stroke collection? Well, so when it breaks the stroke, it creates a new stroke. Aaron, how does it affect the IDs on those strokes?
So every time
this is Aaron Goldberg. He's the ISV architect for the tablet PC, and he can probably answer that better than me.
All right, when you're doing a point erase on any stroke, basically what's happening is that it's occurring a split on that stroke, which will basically split the stroke into two strokes. The earlier part of the stroke will remain as the stroke ID that it originally had. The later part of the stroke after the split will actually be a new stroke in the strokes collection.
And it gets added to the end of the collection.
Absolutely, yeah.
Okay, and so if you affect a lot of strokes when you're doing that, then it just will do that to all of them.
Yeah.
Okay, great. I have another question. I feel like a reporter using my journal notes on my tablet because I had to write them while I was doing
Right
it.
on.
Oh, can you transform a stroke after the fact? I know if you change the drawing attributes, it will affect the stroke as you're drawing it. But what if, can you pick, select a stroke and change it, alter it after the fact?
The question is, can you alter a stroke after it's been collected? I believe the answer to that is yes.
Okay.
Correct me if I'm wrong.
I'll just go play with that and look. It must be a different. It's not drawing attributes. I mean, is it drawing attributes still?
So, are you referring to things besides the drawing attributes? I guess like.
Drawing
XY
attributes
data?
isn't only for what's coming up. It's
right.
just the drawing attributes. Isn't just about what you're about to draw. It's whatever.
Oh no, you can also apply drawing attributes at the stroke level. So after it's rendered.
Okay, so it's not. All right. I always thought it was just what you're about.
Right. So the default drawing attributes property on the ink collection objects, ink collector and ink overlay, those apply to sort of all strokes that are captured. But once that stroke is in the ink object, you can change the drawing attributes of the individual stroke. Absolutely.
Play with that. And I had a question, but I wrote it so fast I can't read it.
Well, you can send me an email.
The keyboard. Wait. It was about the renderer. Oh, well, the renderer. Can you actually affect then with the new where you can grab the I don't remember the term. You just did it as the stroke, real time.
Real-time stylus.
Can you actually modify the bits of an actual stroke? So, say you wanted to.
Can you modify the packet data as it's coming across?
Drawing attributes on different packets?
Well, yeah, but keep in mind that at that point with the real-time stylus, you're not talking about it's before it's rendered. So there's no drawing attributes. It doesn't have the drawing attributes applied yet, right? So you could create an ink collecting object that did its own rendering and do a custom rendering, in which case
Do something like have a line as you draw it, it changes color.
you could change color based on pressure gradient. You can get at the packet data, look at pressure data, and change the color gradient. Do a color gradient based on pressure data, for example.
So that, and then when the stroke is finished, and then it renders it, then you'll see that. You won't see it as it.
Well, no, it depends. If you're creating a dynamic renderer in the real-time stylus, you could have that apply as the stroke was rendered.
Okay. Yeah, I'm such a data entry person.
Yeah. So look at that RTS example, particularly at the custom dynamic renderer, and I think it'll get much clearer to you. You'll see, oh, okay, I can use GDI Plus to do custom rendering of the packet data in there.
Thanks, David.
Yeah, thank you.
The plugins for the real-time stylus, are they custom or are they standard?
The question is, are the plugins for the real-time stylus custom or standard? We provide a couple out of the box for you, but you can create your own custom plugins for the real-time stylus just by implementing a set of interfaces that are documented in the SDK. Question?
The ink overlay, in order to use the eraser, is the only way to do that by implementing events?
So the question is, using ink overlay is the only way to implement erase by listening to events. So you mean, for example, by listening for a cursor, looking at the cursor and seeing if it's inverted and that sort of thing? No, you can do it programmatically, by, for example, providing a button.
I want the user to be able to use the eraser, but when I first got into this, I was working in an environment where it's a programming environment where I couldn't handle events. And it seemed to me that it would be a logical thing to be able to both draw and erase without having to take it to the next level of programming in order to just handle the fact that the user flipped. I mean, you could have the pen in an automatic mode. You could have the stylus in an automatic mode.
Right. So we do sort of leave that up to the developer to implement as they see fit, because there's several considerations there. First of all, the pen may or may not have an eraser end on it, so you'll want to provide alternative means for the user to get into the erase mode. So, for example, that button example is a way you could do that. Also, you may or may not desire for the inverted cursor on the pen to be erase, even if it's available. Certain people may want that to be, for example, a highlighter instead of an erase mode. And so we leave that flex. We don't define that that's an eraser mode, just that we tell you this is a cursor on that pen device, and it's inverted. And then you treat those properties as you want to make it customized.
Default behavior.
Would be erase, yeah. But that was one of those trade-offs where we decided, provide sort of the customizability and flexibility to make the UI do exactly what you want versus sort of locking you into a behavior. Yeah, that's a good question.